Hello, 7th graders, and welcome to Chapter 12 and 13, which are in one unit together. These are on probability. So in Chapter 12, we'll be looking at experimental probability, and then in Chapter 13, we'll be looking at theoretical probability, and we'll be comparing the two. All right, before we get started, there are some key words we need to know. So with probability, we're going to be looking at making mathematical predictions. To do that, we're going to need some words, some vocab. So remember, this is what we call a percent, and this is what we call a ratio. We can describe probability with both percents and ratios, and we can even use fractions and decimals. Facts used to make decisions are what we call data, and the act of collecting facts is through observation. Now we use observation, data, and then ratios and percents to make mathematical predictions. All right, and then some new vocabulary for this chapter. Probability measures the likelihood that an event will occur. An event is each observation of an experiment. And then a trial is a set of events or a set of one or more outcomes. All right, let's begin by finding the likelihood of an event. The experiment that we'll be looking at is rolling a dice. A dice has 6 faces, numbered 1 through 6 on each face. So rolling each number, 1 through 6, is called an event. Rolling a 1 is an event, rolling a 2 is an event, etc. So they listed some events here. We're going to describe how likely they are, and then we're going to rank them in the boxes over here. So the first one, rolling a number less than 7. We are certain that that will happen because every number on the dice is less than 7. Whether we roll a 1 through a 6, it's going to be less than 7. All right, rolling an 8. This is impossible. There is no 8 on that dice. That's not going to happen. All right, rolling a number greater than 4, that would be 5 or 6. Well, that's 2 faces out of the 6 faces. So that has 1/3 of a chance that that's going to happen. So there's 2 events that would fit that out of 6 possible events. We just simplified 2/6 to 1/3. All right, rolling a 5, that's only 1 event out of these 6 possible events. Rolling a number other than 6, well, there's 5 numbers other than 6 out of these 6 possible events. Rolling an even number, that's going to be 2, 4, or 6. So that's 3 events out of the 6 possible. We can simplify that fraction to 1/2. Rolling a number less than 5, well, that's 1 through 4. So that's 4 events out of the 6 possible, or 2/3. Rolling an odd number, well, that's the same as even, except it's the opposite, 1 through 5. So that's going to be 3 events out of 6, or 1/2. And then rolling a number divisible by 3. Remember, divisible by 3 just means it can be divided by 3. So the only numbers that work for that are 3 or 6. So that's 2 events out of 6 total, or 1/3. All right, so now we're going to look at these events, and we're going to rank them by the ones least likely to the most likely to happen. Well, we know rolling a number less than 7 is the most likely, so we'll put a 9 there. And then we know rolling an 8 is impossible. It's the least likely, so we'll put a 1 there. All right, now how we're going to rank them. We'll start with the least likely. So the next one is going to have the smallest fraction. So if we're looking at the smallest fraction, all of these are fractions over 6, or then simplified to 1/3 or 1/2. But we'll start with the number over 6 to rank them. So 1/6 is the next smallest. That's going to be 2. And then anything with 2/6 or 1/3 will be next. So this is 3 or 4. These are tied. They're both 1/3, 3 or 4. And then the next one will be anything with 3/6 or 1/2. So that's 5 and 6, 5 and 6, they're tied. And then next will be 2/3, so 7. And then next will be 5/6 or 8. Okay, so hopefully what you got from this page is that rolling a number less than 7 on a dice is for sure going to happen. Rolling an 8 is impossible, and yes, it's okay to describe events as certain or impossible. And then hopefully you kind of understood where we did here, 3 events out of 6 or 4 events out of 6. That's what we're going to be looking more at in chapter 12. All right, so in this section, we're going to look at describing events. An experiment is an activity involving chance in which results are observed. Each observation of an experiment is a trial, and each result is an outcome. A set of one or more outcomes is an event. So the probability of an event, written as P of event, measures the likelihood that the event will occur. That's an important vocab word. The probability, written as P of the event, measures the likelihood that the event will occur. Probability is a measure between 0 and 1. It's shown on a number line, can be written as a fraction, a decimal, or a percent. If the event is not likely to occur, the probability of the event is close to 0. If the event is likely to occur, the probability is closer to 1. So notice here, certain is 100%, and then impossible is 0%. Example number 1, tell whether each event is impossible, unlikely, as likely as not, likely, or certain. Then tell whether the probability is 0, close to 0, half, close to 1, or 1. All right, you roll a 6-sided number cube. The number is 1 or greater. Well, every number on a number cube is 1 or greater. So this event is certain to happen. The probability is 100%. Okay, B, you roll 2 number cubes, and the sum of the numbers is 3. This event is unlikely because if you're rolling 2 different cubes, one would have to be a 1 and the other would have to be a 2. So the chances that you get a 1 on one and a 2 on the other is not very likely. This probability is close to 0. It's possible. It's not 0%. It's possible, but it's close to 0. All right, a bowl contains discs marked with the numbers 1 through 10. You close your eyes and select a disc at random. You pick an odd number. So half of the numbers 1 through 10 are odd. So the chances that happen are literally 5 events out of 10. The probability is 1/2. That's as likely as it is not likely. All right, last one. The spinner has 8 equal sections marked 0 through 7. You spin and land on a prime number. Well, let's think. What is a prime number? A prime number is a number only divisible by 1 in itself, and it has to be greater than 1. So 0 and 1 don't count. So our prime numbers between 0 and 7, 0 and 1 don't count, so 2, 3, 5, and 7 are all prime numbers. Well, that's 4 out of 8 sections, so this event is as likely as it is not likely because the probability is 1/2, or 4 out of the 8 events is 1/2. All right, so we've talked about the likelihood of an event, but what about actually finding probability? How do I get that fraction that explains our probability? Well, let's take a look. The sample space is a set of all possible outcomes for an event. That's what I've been using as the denominator, the bottom number. A sample space can be small, such as only 2 outcomes, like when a coin is flipped heads or tails, or the sample space could be large, such as the possible number of Texas Classic automobile license plates. Identifying the sample space can help you calculate the probability of an event. So how do we calculate that? The probability of an event is the number of times the event occurs or could occur over the total number of equally likely possible outcomes. So when we roll a dice, that bottom number is always 6 because there's 6 sides of the dice. Then the top number depends on the event. So if it was rolling an even number, Well, there's 3 even numbers on a dice. That would be 3 out of 6. If it's rolling a 1, that's only 1 event out of these 6 possible events. Or like we saw on the first slide, if rolling a number less than 7, well, all 6 numbers are less than 7, so 6 out of 6 would be 1, or certain that that would happen. All right, so let's practice actually calculating probability. What is the probability of rolling an even number on a standard number cube? So the sample space is numbers 1 through 6. Those are the 6 possible outcomes. Then we determine the number of outcomes that would match the event given. So the outcomes that are even are 2, 4, and 6. So that event can occur 3 ways. There are 3 possible outcomes that fit that event. So the probability is going to be the number of possible outcomes, the possible ways that that event can occur, over the total number of possible outcomes. So 3 over 6, or 1/2. We could also say that that's 50%, or 0.5. All right, your turn. Find the probability of both of these numbers, 4 and 5. So pause the video, read the problems, see if you can figure out the probability, and then play it back to see if you got them right. Go. All right, I'm going to go over the answers. So number 4, picking a purple marble from a jar with 10 green and 10 purple. Well, that's 10 purple marbles out of 20 marbles total, or 1/2. Or you could have written that as 50%, or 0.5. And then the second one, rolling a number greater than 4 on a standard number cube. Well, the only events greater than 4 are 5 and 6. So that's 2 out of 6 possible outcomes, or 1/3. All right, so another vocab word that we're not going to go as in-depth with, but we will touch on, is the complement of an event. The complement is the set of outcomes that are not included in the event. So, for example, if the event is rolling a 3, the complement would be not rolling a 3, which means numbers 1, 2, 4, 5, or 6 would work. So an important math thing to know about this is that the sum of the probabilities of the event and its complement equals 1. So if we're using that example still, the probability of rolling a 3 is 1 out of 6. The probability of rolling a number other than 3 is 5 out of 6. 1 6 plus 5 6 equals 6 6, or 1. So basically that's just saying if the probability of an event is 1/6, then the probability of that event not happening is 1 minus 1/6. Okay, so you can apply probabilities to situations involving random selection, such as drawing a card or pulling a marble out of a closed bag. So if we're talking about a deck with 52 cards, and it says what's the probability of not getting a card, instead of listing out the other 51 possible cards, it's easier to just say, okay, 1 minus that 1 card, and find the probability of it not happening. So let's look at this example. What's the probability of not getting a red jack if you select 1 card at random? Well, there are only 2 red jacks out of the 52 cards. So the probability of getting a red jack is 2 over 52. So then the probability of not getting a red jack are the other 50 cards. So 50 over 52 is the probability of not getting a red jack. And then of course we simplify, and that's 25 over 26. All right, so I'll have you guys try this on your own real quick. Pause the video, try numbers 7 and 8, and then play it back to see if you got them right. All right, I'm going to go ahead and go through them. Number 7, a jar contains 8 marbles marked numbers 1 through 8. You pick a marble at random. What's the probability of not picking a marble marked with the number 5? Well, the probability of picking the 5 is 1 out of 8. So the probability of not picking the 5 is the other 7 numbers over 8. That's your answer. All right, number 8, you roll a standard number cube. Use the probability of rolling an even event, or an even number, to find the probability of rolling an odd number. Well, we know there's 3 even numbers, 1 through 6, so that means the other 3 are odd. That would just be 3/6, or 1/2 if we simplify. All right, your homework today is just the notes video, but tune into our Google Meet to find out what your homework is the next day. Probably going to assign these 10 problems at some point. So if you want to read through any now, check your understanding, go for it. Otherwise, have a great rest of your day.